Okay, so let's do in class 7, number 1. It says find all relative extrema and saddle points for the given function. So here's a function. So let's first find with respect to x. It's going to be 3x squared, that's gone, minus 3y. And we'll find also fy, that'd be 3y squared in that one. So it'll be minus 3x in this one. Let's also find f double x. So here's my fx here, so f double x would be 6x. Let's find f double y. Here's fy, so derivative with respect to y would be 6y here. And let's do the mixed one. So fx, y, so fx, y out here. So I'll be looking at my fx, taking derivative with respect to y. So let's the constants go, so it'll be minus 3 here. Okay. So now, fx equals 0 and fy equals 0 implies, so here's my fx and fy, it implies then that if the system 3x squared minus 3y equals 0, let's call this equation 1. And the fy, so 3y squared minus 3x is 0, let's call this equation 2. So you have to solve the system. So what I'm going to do is say, let's solve the equation 1 for y, say. So solve equation 1 for y. So you have then 3x squared minus 3y equals 0. So then adding 3y to both sides, you'll have then 3y equals 3x squared. Dividing by 3, the amount of y equals x squared. Okay, we're going to substitute this now into equation 2. So sub into equation 2. So in particular, in place of y, I'm going to write x squared. Okay, so let's do that. Okay, so substituting y equals x squared into equation 2. We're putting x squared in place of y here. So we get then 3x squared minus 3x equals 0. Okay, so then we can write this as 3x to the 4th minus 3x equals 0. And we can divide both sides by 3. Then x to the 4th minus x equals 0. Then we can factor an x out. So the x times x cubed minus 1 equals 0. So have then x is 0, or x cubed equals 1, or x cubed, say, minus 1 equals 0. So we'll have x equals 0, or x cubed equals 1. This implies then, taking cube root on both sides, x is 1. So here's our two answers. So now, recalling that y equaled x squared, and x equals 0 and x equals 1 implies, so at critical points, Okay, so x could be 0. Now y equals x squared, so that means y would be 0 in that case. And x could be 1, but y is equal to x squared, so we have 2 critical points. So we now have to decide whether these will be relative max, mins, or saddle points. So we're going to use this then. So d of AB equals f double x AB f double y AB minus f xy AB squared. Okay, so recall we found that f double x was 6x. F double y was 6y, and fxy was, I erased it, but it was, say, minus 3. All right, so let's figure out these things. So then d of 0, 0 is going to be f xx of 0, 0, fy of 0, 0, minus fxy 0, 0 squared. So this will be 0. This will be also 0. It's going to be minus a minus 3 squared. This is less than 0. This implies that, so hence, f of 0, 0 is a saddle point. Again, because whenever d is negative, looking at the theorem, second derivative theorem, whenever d is negative, it would mean that we have a saddle point. Okay, so let's keep going. All right, so let's do d of 1, 1 now, set up here. So d at the point 1, 1 is going to be f double x of 1, 1, f double y of 1, 1, minus f xy 1, 1 squared. So again, here's my f double x, f double y, xy. So putting 1, 1, so 1 for x, 1 for y, this would be 6. Oops, 6 here. F double y would be 6 also. And this would be minus 3 squared. So the 36 minus 9, which is positive, that's all you care about. And also f double x is positive. So it means it's concave up. So hence, I'll be a minimum then, min at f of 1, 1. Okay, so we're done.